In schematic window you should use mills, because all these default symbols they are made with mills. To change mills you can go to preferences, and here we have this grid. I'm using mills for symbols and millimeters for footprints and PCB design. So here we have this mills, and if we drag component here, and if we just drag this here, it already connects there, so everything works. Now we can try same thing, but instead of mills, if we have millimeters. Let's see what happens. So we place this here. And we can wire that there, it works, but now this data, we will notice it won't go there, because this symbol is created in mills. So it doesn't work so good. Of course we can draw this line from here there, but still there is some random things like this. They are not aligning. Here we have schematic of this project. So if we change some values or just add new resistor, example, let's just place this one. So placing this, and we place it here. So after saving, you should always wait until all these have updated, because if you don't wait until all these updates, there might be some problems in this PCB wheel. Like sometimes if I have rust doing this wheel, there might have been some connection problems between components, and you have to synchronize all components again. So it's good idea to wait until this thing has synchronized after saving. Sometimes you have to create new components, and for that I recommend you to use this package manager if possible. Here is list of many different package sizes, and you can select any of them, and you can even custom these dimensions. And this package manager will automatically create footprint too. So all you have to do is create symbol for this new component. If you have to 3D model this, it will take a lot of time, so it's good idea to use this package generator. In this project I had to test many different coils, so instead of using normal electric components, I used empty 3D model for this coil, and then I have just normal 3D model here, so I can easily change different coils here. If we go to this PCB layout, here we have this coil component and this through holes, but there is no any 3D model for this component. So sometimes it's good idea not to use any 3D model for component if you have to test many different. In this project I had this custom PCB board which have a lot of SMD components. In Fusion you can generate pick and place files, but it is not in correct format, so you have to modify that. So here I have, this is for GLC PCB, so they use this format. So it's good idea that you use the pick and place file which is generated by Fusion, but then you have to modify it a little bit. In Fusion we have a lot of these SMD components. So if we go here, we have all these default package size, and we can use them. So if possible, it's good idea to use these SMD components, because example this through hole capacitors there is only this two size, but there is so many this SMD size, and usually these through hole capacitors, they are not having same dimensions as what the component you have has, because all these diameters and pin holes and distance between pin holes, there is so much differences in all components. So but SMD components have this standard size, so it's good idea to use them. Using 3D viewer often with all assembled components is good idea, because this is the only way you can verify you can actually assemble this board and not any component or bolts are overlapping anything. So here we example see this bolt, and then we have this much space here, so we can easily connect these bolts here. Then here I have this very custom power MOSFET with this custom 3D model, and I actually had to make these legs like this for to save space and to make this so I can solder. So normally these legs would go here, and this would be very hard to solder, because here's this capacitor legs which have to solder, and then I have to solder this. So it's good idea to check 3D model and make sure you can actually reach all components and assemble the board. Before manufacturing this board, it's good idea to run this DRG check, so it will check everything is correct. If we click here, check, and now we get this unrouted air wire, so there is something which is not connected, and now we can click this and we'll show it. So we have this 5 voltage line which is not connected, so we can connect that, and it is from here, so it's this one and it needs to connect there, so we can draw this, and now all these errors disappeared and this DLG check is approved. If you make custom components, it's good idea to make this through hole parts little bit bigger. So example here we have this leg from this capacitor, so it is this 1.3 millimeters, but I have created this hole, this is 1.63, and actually in footprint I think this was like 1.7, but then there is this copper which will also reduce this size little bit. But it's good idea to make these holes little bit bigger, because it can be very annoying if you have ordered the board and these holes are not large enough and you can't actually assemble components. If you have bigger projects where is many components, it's good idea to make this little bit more documented, like adding all these text, what is what, and then you can add these lines and make like segments here. For this you can go this document section, and then here is this, and you can change like this short dash, and you can, I think I use these names maybe, and you can draw this boxes here, and then you have your have your components there, and then it is a little bit easier to read when you know what components are for what and what they do there.